about it. So a radical, or we call it a square root, is a simplified form if no perfect square factors of the radicand remain, no fractions are under the radical, and no radicals are in the denominator. So let's quickly talk about perfect squares, because it says no perfect square can actually be underneath the square root bar. In other words, if I had square root of 9, what does square root of 9 equal? Equals 3. So that would be the simplified form. Square root of 9 is not simplified. 3 would be simplified. So let's talk about what it means to be a perfect square. So our perfect squares, I put a little note here if you're not sure. Our perfect squares are going to be a list. It starts with 1. It starts with 1 because 1 squared equals 1. Our next perfect square comes from, if you do 2 squared, it would be 4. So our perfect square is 1. It's 4. 3 squared equals 9, so 9 is a perfect square. We also have, if I do 4 squared, that would equal 16. And we do 5 squared, it'd be 25. 6 squared would be 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. You don't necessarily have to have them all memorized, but you should have a general idea of at least up to 12. Like what's 12 squared is. So like 144 should be the big one. 121 you should recognize in there. So your perfect squares are just going to continue on forever. Now, my goal is not to confuse you and have 6,877,501 under a square root, and you have to find the perfect square. They're typically one of these smaller ones. So you just kind of have to trial and error, and having your calculator out is a good idea when you're solving these. So let's go through a couple of these. So the first one is, what's the square root of 64? What's the square root of 64, David? 8. That just equals 8. So a simplified form would just be 8. And why it's 8 is because 8 squared equals 64. In other words, it's another way to look at it. The square root of 64 would equal the square root of 8 squared. And a square root and a square cancel each other out. They're inverses. So if you take a square root of something squared, you're just left with that 8. I don't expect you to show all that work. You should just go square root of 64 is 8. We got it. We got it, Mr. Pavian. All right, square root of 32. Is there a perfect square that goes into 32? Like, can I go square root of 32 equals 6? No. But in order to be simplified, I can't have a perfect square, any perfect squares underneath it. So what perfect square would go into 32? If we look at our list of 1, don't ever choose 1 because it doesn't get you very far. Jacob?
16.
16 goes into it. So we could rewrite this as square root of 16 times 2. Was anyone thinking of a 4? And if you used a 4, you get to the same answer. Let's go ahead and use a 4 in just a second. This way is a little quicker because we have square root of 16 times 2, which you can break that apart into square root of 16 times square root of 2, which is just going to equal 4 square root of 2. Yeah, John.
What if I did 2 times the square root of 8? What if I got that as a answer?
Then you made a mistake. What did you do? What was your first step, I guess?
I did 4, the square root of 4 times the square root of 8.
Okay, so let's do that. Let's do your method and see how it would come out. So another method is, sometimes these numbers get really big, and you're just like, okay, I know 4 goes into it. I know 9 goes into it, but there might be a bigger one. And in this case, 16 went into it, but let's start with 4. Let's start with 4. Let's go, okay, I think 4 is the biggest perfect square that goes into it. So we'd have 4 times what equals 32? You said it, right? I think you said 8.
Wait, what?
You said 8, right?
Yeah.
Yep. So 4 times 8 equals 32. So I have kind of where you started off, right? Well, that's going to end up equaling, are you okay with me going 2 square root of 8? Is that what you simplified it to?
Yeah.
Is there a perfect square that goes into 8? Yeah. 4 and 2. So you have to try it again. All right, when you have like 8s or something, try something else. So we can break that down further into 2 times that square root of 4 times 2. I'm kind of running out of room, so let's come down here. Which is going to equal 2 times the square root of 2. Not the square root of 2, square root of 4 times the square root of 2. Square root of 4 is 2, so that would be 2 times 2, so we'd end up with 4 square root of 2. You just be very careful when you're dividing. Check something else, especially when it's like 8. Because the only thing you really have to check is 1, but we're not going to check with 1, but then 4. And what's great is on your calculator, good idea is when you have your numbers and you know your perfect squares, so say it's a big number. Say it's 216. What I would do is in my calculator, I do 216 divided by 4. 216 divided by 16. 216 divided by 25. Just try your perfect squares you know, and see if you can find that biggest one that goes into 216. I'm going to give you a second. I'm going to give everyone a second just to try it. See if you can find that biggest perfect square that goes into 216. There's something you can eliminate right away, because can 25 go into 216? No. 9 might work. 16 might work. 36 might work. I would try all of those. Who thinks they have the biggest perfect square that goes into it? Labib. 9? I think there's one bigger. 9 would work? Yeah. 36 actually goes into it. 36 actually goes into 216. So you could think of this as square root of 36 times 6, which would just equal the square root of 36 times the square root of 6, which is just going to equal 6 square root of 6. Labib, you said 9 goes into it? Let's try that. So we can rewrite square root of 216 as square root of 9 times what?
24.
Times 24. So 9 times 24 equals 216. So if I was going down this method, right, we'd break that apart and we'd say, well, square root of 9 times square root of 24 equals it, which would be 3 times the square root of 24, right? So I ended up with 3 square root of 24. Is there a perfect square that goes into 24? 4 goes into it? Mm-hmm.
4 times 6.
Yep, it'd be 4 times 6. What's the square root of 4?
2.
What's 2 times 3?
2 or 6.
6. So we'd end up with the same answer, right? You just have to go one step further. When you get a big number like 24, if you get like 30, like a bigger number, just check to make sure there isn't a perfect square that goes into it. If you're all the way down here, so if you look at the first one, we had 36 times 6. We're like, well, that's got to be the biggest one because nothing goes into 6. It should be a nice small number. If it's not, just double check. Perfect squares don't go into it. All right, so we'd see that this would work out the exact same way because we'd have 3 times the square root of 4 times the square root of 6, which would just be 6 square root of 6. Same answer. Just a little extra step. So what I always like to do is check the big ones. Check your 36s. Check your 25. See if they go into it. Don't stop at 4 and go, oh, I'm done. Go a little further. Just try it. It saves you a little time in the end. All right, any questions on simplifying those 3? All right, let's move on. Ooh, those are the same ones. All right, so square root of 14 squared. What does that equal? It shouldn't take any work. Shouldn't take any work, yeah. It should just equal 14. It equals 14. Because like I said, these are inverses of each other. These are inverses of each other. So a square root squared, they both cancel out and they're gone. So two ways to look at that. So my first way I was like, okay, they cancel each other out, so I kind of cross them out. Another way you can look at it is, well, square root of 14 squared would be the square root of 14 times the square root of 14, which would end up just being 14. Yep. And if you don't believe me, let's do a secondary case underneath it. Let's say I'm doing square root of 9 squared. All right, and let's write it like I did above. That would be square root of 9 times the square root of 9. What's the square root of 9? 3. What's 3 times 3? 9. It just equals 9. So in other words, any number that you have, the square root of x squared will always just equal x. Always. They're inverses of each other. All right, plugging around. We have 5 square root of 7 squared. If you're really good at these, you don't have to rewrite them. But what I'm going to do is I'm going to go ahead and rewrite this. Since it's being squared, I'm going to rewrite it as 5 times square root of 7 times 5 square root of 7. That's what squared means. It means multiply this twice. All right, I'm going to organize it because I can move these around. Right? Like 5 times 3 times 4 is the exact same thing as 4 times 3 times 5. So we can move these around. I'm going to put the 5s by each other, and I'm going to put the square root of 7s by each other. So this is just going to equal 5 times 5 times square root of 7 times square root of 7. Well, 5 times 5 is easy. That's 25. What's square root of 7 times square root of 7? Yeah, it's just going to be 7. And what's 25 times 7? In other words, how much money do you have if you have 7 quarters? Yeah, 175. I'm going to show you a different way to do that, because that was nice to have different ways, especially if you're trying to do it in your head. You can rewrite 5 square root of 7 squared as being 5 squared times square root of 7 squared. So you're almost like distributing that square to both items in there, as long as it's all being chained together by multiplication. Yes?
Could you spell it like square root of 25 times square root of 7, and then
Yep.
put those together, and
Mhm.
it would be like square root of 175.
Yep. So Jacob came up with a good idea. Well, 5, I can revert to square root of 25. And the square root of 25 times square root of 7 would be the square root of 175. Square that, and we end up with 175. So there's lots of different ways to do these. Our next one, we have 3 times square root of 6 times 5 times square root of 12. So what I do is I line up the things that are underneath the radical and things that aren't. So I'm going to rewrite this as 3 times 5 times square root of 6 times square root of 12, because that gets us to another thing that we can do. Well, 3 times 5 is just 15. When you have a radical being multiplied by another radical, and they're not the same, we have square root of 6 and square root of 12, we can rewrite both of those underneath one radical. So I can rewrite this as, not 16, 6 times 12. Do you all kind of remember that? Maybe?
Yeah.
Sort of? Yeah. You've seen it. So if you're multiplying radicals, you can put them all underneath one radicand. All right, so we do that. So we have our 15. We have our 6 times 12. So we're going to have 15 times 60, 72. Am I done? Is square root of 72 this simplified? People are saying no, so that must mean there's a perfect square that goes into it. What perfect square goes into it? 9 does. Is there a bigger one? Would 9 work? Would 9 work? Yeah, it just takes a little, what's it? 36. 36. But 9 will work, right? Don't spend your whole test finding the biggest one that goes in. If you're just like, I think 9 works, do it, and just be like, okay, that's still a big number. I can find another perfect square that goes into it. I'm just going to use the 36. So we have 36 times 2, which equals 15 times the square root of 36 times the square root of 2. Well, the square root of 36 is just 6, so we have 15 times 6, so that'd be 60 plus 30 is going to be 90. So we'll have 90 square root of 2. Do I need to see all these steps from you? No. If you're good at this, you can skip stuff. I don't need to see it all. But you should at least give me the gist of what you're doing in case I don't want to see this equals, like 45 square root of 2. I don't know where your mistake is, and you just lose points for him and say you don't know how to do it. Yeah?
Could you break the, 12 into...
Yeah. Mm-hmm. Yep, you absolutely could. There's multiple ways to do this. So if you're talking about breaking the 12 apart, just because then you have a square root of 6, right? And then you have a square root of 6 times a square root of 6. So that just becomes 6. Yep, multiple different ways to do all of these. What's wrong with number 7? It's asking me to simplify. What's wrong with it? Labib. Fraction's okay. There's a problem with the fraction, though. Yes?
A radical in the denominator.
You can never have a radical in the denominator and have it being simplified. So we need to get rid of this square root of 2 in the denominator. Yes, EJ?
We could do radical 2 over radical 2.
We could do radical 2 over radical 2. Because what's happening in my mind is, well, the only way to get rid of a radical. So the only way to get rid of square root of 2 is to actually multiply that bottom by square root of 2. Because what's square root of 2 times square root of 2? 2. Am I allowed to just multiply whatever I want, anywhere I want? Does this stay balanced if I just multiply this bottom by square root of 2? No. So to keep it balanced, I'm just going to change this to square root of 2 over square root of 2. Because last time I checked, square root of 2 over square root of 2 is just 1. Am I okay if I multiply something by 1? Yeah. So I just need to multiply the top and bottom by square root of 2. Which on the top, we're going to have 3 square root of 2 over square root of 2 times square root of 2 is just 2. Then I'm going to ask myself, are there any perfect squares that go into 2? No. We're good. That's our answer. That's fully simplified. All right, the next one we're going to deal with is fractions. This actually falls under the exact same rule as over here. Your denominator cannot be underneath the radical. This radical covers the numerator and the denominator, so it's not going to work. Because you can rewrite this when you're dealing with a division underneath a radical symbol, is I can have the radical on top and bottom. Those two things are equal to each other. Just like with multiplication, you can pull it apart and push it together. Same thing with division. You can break it apart like this, or you can push them together and have them all underneath one radicand. All right, so we have square root of 4 equals 2 over square root of 7. Well, you still can't have a square root in the denominator, so what you're going to do is you're going to multiply the bottom and top by square root of 7. We'll bring this down here. We'll have 2 square root of 7 over just 7. And we're done. There's no square root in the denominator. Square root of 7 is as simplified as can get. There's no perfect square that goes into 7. Questions on that? There is a whole lot of different ways to do number 9. There's a whole bunch of different ways to do number 9. So I'm not going to... and there's not enough room to really do all of them. So I'm just going to talk about one method you could do, and I'm going to do something else. So one method you could do. I'm not going to do this. If you want to write it down, you can, but this isn't the method I'm going to end up following. You could rewrite this as 4 times. This is kind of the harder one to look at. You could rewrite this as 4 times square root of 3 over 24. And then you could deal with the fraction. Because 3 goes into it, you could change it to 1 over 8, and then you could work from there. Sometimes I find that method gets a little confusing for people. So rather than doing that, I'm going to kind of stick with the exact same thing we did over here. I have a square root in the denominator, so let's get rid of the square root in the denominator and then simplify from there. So in order to get rid of that square root in the denominator, we're going to multiply the bottom and top by square root of 24. You could have also simplified square root of 24, but we're not going to do that. We're just going to go, let's just brute force this. So we'll have 4 times square root of 3 times square root of 24 all over 24. Well, the good news is I don't have a radical in the denominator. I just need to simplify that numerator. I just have to simplify that numerator. Well, because I have square root of 3 times square root of 24, it's a multiplication. I can then rewrite that as 4 times radical 3 times 24 all over 24. Did I lose anyone yet? Okay. Then we just got to do 3 times 24. Well, that's going to be 3 times 2 is 6 plus 12 is 72. So we're going to have 4 times the square root of 72 divided by 24. Well, once again, I don't have a radical in the denominator, so I'm not worried about that. But I'm worried about that square root of 72, because 72 seems pretty big, that there's a good chance that there's a perfect square in it. Jacob?
Can you switch that to 1 over 6?
You can. Yep, I'm going to wait till the end to do that. Yep. But Jacob was just saying, can you change this to 1 over 6 because we can reduce this fraction? I'm going to do it at the very end. Square root of 72. What perfect square goes into 72? Yeah. I think you gave me that one too. Yeah, it's 36. So we can rewrite this as 4 times square root of 36 times square root of 2 over 24. Well, that's going to be 4 times 6 times square root of 2 over 24. Well, 4 times 6 is 12 plus 12, which is 24. So we have 24 square root of 2 over 24, yeah.
You simplify. I don't know.
You sure?
Yeah.
Because we can simplify a little further, because what's 24 over 24? Yeah, 1. It just equals 1. So it's going to just equal square root of 2, surprisingly. So Jacob, I waited to simplify it because I knew what the answer was. Right? Because you simplified in that step and you came up with that one, and then you ended up with, I mean, you could come up with the same answer, right?
Yeah.
Any questions at any of those steps? Yeah. Cooper. You sure?
Yeah.
Positive. All right, because that's probably the hardest one. It's, okay. Because you did, this has almost everything in it. It's got a square root in the denominator that you had to deal with. It had a multiplication of square roots, putting underneath 1 bar. And it had simplifying 72 to be square root of 36 times 2. Questions, comments, concerns? All right, then the rest of the time is yours. If you look online for the answer key, there is no answer key, because if you look at the very end of the lesson, all the answers are right there. And if you absolutely can't do something, just put a little question mark by it, and then we'll go over it tomorrow together. Jacob? Yes?